Well, hello everyone. This is Bonodasi, and we have the exchange app here. The exchange is a cross-chain bridge between Polygon and Sepolia, and you can use it to bridge NFTs and cryptocurrency from one network to the other. There are two versions of it basically. There is a centralized and a decentralized one. And as we will see, both of these versions, they are quite similar in terms of the functionality that they provide, but in terms of the implementation of how the assets are bridged from one network to the other, they are starkly different. We will see more about the difference between the two later in the video. This app is powered by Ethereum-based smart contracts on the backend on both Sepolia and Mumbai testnets and React on the front end. Now, in order to push transactions to the blockchain, we will need MetaMask, but in this demo, we will not be pushing transactions to the blockchain. So we will not need MetaMask actually. We will quickly overview the features and functionality of this app. Starting off with the centralized one, here are six sections basically, and we will quickly overview each of the sections one by one, starting off with the NFT. Here you can basically mint an NFT, choosing an image, a name, a description, and clicking the mint button here, signing the transaction, and NFT would be minted. Now, as I can see, uh, it is taking a bit long to load the NFTs, and that is because the NFTs are basically stored on the blockchain. The metadata of the NFTs is stored specifically on the IPFS, so it is taking a bit long actually. Um, this is an NFT that is already been minted. Um, and it is on the Mumbai network currently, and it is identified by this item ID 4. Now, from here, we can basically bridge this NFT to another network. It is on Mumbai network currently. So if I choose Mumbai in the from section here, filling in the item ID and choosing Sepolia here, if I click send to network, I would be shown with this MetaMask pop-up, and signing this transaction, this NFT would be transferred to that another network. Next up, we have the exchange section, and from here we can basically bridge cryptocurrency and specifically ETH from one network to the other. Like if I select Mumbai as the source chain, Sepolia as the destination, and choose 10 GUI as the amount and click transfer, what would really happen is that 10 GUI of ETH from my address on the Mumbai chain would be debited, and correspondingly on the Sepolia chain, the very same address would be credited with 10 GUI. And within these contract balances, what would really happen is that the Mumbai contract balance would be credited with the 10 way that I transferred, and the Sepolia would be debited with 10 way. Now, what you might be thinking is where are all these funds really coming from that are being used to bridge? These funds are basically coming from these deposits here, and you can basically stake Ethereum here, provide liquidity to the bridge, and you can also earn interest on your deposits, and the interest rate would be dependent on the duration for which you are locking your assets. Like if you lock your assets for longer period, you would be earning a higher interest rate, and once that locking period has passed, you can also withdraw your funds. That was the ETH exchange and deposit. Next up, we have the loan. Now we do know that this application does hold funds that it has gotten through the deposits here, and these funds, they are not only used for bridging transactions, they are also given out as a loan. Now, in order to get a loan, we need to get KYC done first, since it is a centralized exchange. We can get the KYC done here. It is redirecting to this another page, and here we simply add the name, the date of birth, and a KYC code would be generated. We need to copy the KYC code and submit it here. Once the KYC code is submitted, KYC would be completed, and we would be given a credit score. Now I have another account for whom the KYC is complete. Signing in with that another account. Uh, this account has its KYC completed, and I have been given a credit score of 75. And the loan amount, the amount of loan that I can get is dependent on this credit score. We can move to the loan section here now. But still, in order to get a loan, we need to stake as collateral an NFT that we own. And once we do stake that NFT as a collateral, we would be given the loan amount. And for as long as we have not repaid the loan, that NFT would be owned by this app. And once we do repay the loan, the NFT would be transferred back to us. It is taking a bit long to load this loan page, and that is because it is loading the NFT, the collateral NFT. It is loaded, and what we can see here is that I am eligible for 1500 way of loan as per my credit score of 75. And here we can see the NFTs that I own. I own this NFT, and this NFT is on the Mumbai network with an item ID of 4. And filling in the details here, we can get the loan. The item ID of the NFT is 4, and the network of the NFT is Mumbai. Here we can select the network on which we require the loan amount of ETH. I can select Sepolia here. And since we are eligible for 1500 way of loan, we also do have to take into account the balance of the smart contract of the app. Like the smart contract currently holds 47 way of Sepolia. So we cannot, ask for loan amount greater than 47. So I can ask for 20. And here we can select the loan period for the duration for which we require the loan in seconds. Basically, I can select 200, and clicking the button here, we will have to sign the transaction and we would be given the loan. Now, in the circumstances that we are unable to pay the loan within this stipulated time period, this collateral NFT, it would be moved to the marketplace section, and it would be put for sale for the amount of loan for which it has been given as collateral. And then basically anybody can go there and buy that NFT for the corresponding amount. This was the centralized version of the app. Now we will look at the decentralized version, and it is gonna get very interesting. This is the decentralized version of the app, and as we can see, this this section actually looks quite similar to the centralized one. The NFT section, the deposit section, the exchange. We can bridge NFTs here, mint NFTs here. We can bridge Ethereum here. We can get a loan. There is no KYC here since this is a decentralized exchange. No need to get KYC done, but we can get the loan in the very similar way by giving as collateral an NFT, and in much the similar way there is this marketplace section here too. But what really makes this decentralized version of the exchange app different from the centralized version is the implementation of how the assets are actually moved from one network to the other. Well, we can better understand the difference between the centralized and the decentralized version of the bridge using these two diagrams. The top one shows how the decentralized bridge works, and the bottom diagram shows how the centralized bridge works. But let's take a step back and really understand how this bridging is actually working. What is really happening here? Um, well, we do know that we are uh, depositing assets on one network and getting the corresponding assets on the another network. For example, if we deposit Sepolia ETH on the Sepolia network to the Sepolia smart contract, correspondingly, smart contract on the Polygon network is depositing Ethereum on the Polygon network to the very same address. So the Ethereum from the Sepolia network is transferred to the Polygon network. But the issue here is that both of these networks, they do not have any proper communication channel between the two. So the smart contract on the Sepolia network cannot communicate with the smart contract on the Polygon network. So in order for the bridge to work, what we really need here is a relayer in the middle that would help both of the networks communicate with each other. And this central relayer is what actually makes centralized and the decentralized version of the bridge different from each other. Like in the case of centralized bridge, the relayer is a centralized server. And what this server really does is listen for transactions on the source chain and submit corresponding transactions on the destination chain. Like if I have to transfer ETH from Sepolia to Polygon, what I would do is deposit ETH on the Sepolia smart contract. The centralized server would register the transaction and then direct the Polygon smart contract to deposit the corresponding amount of ETH to my very same address on the Polygon chain. Now, this all works. But the issue with this design, with this implementation, is that there is too much concentration of power with the centralized server. Uh, this server might get hacked, it can be compromised, it might get malicious. And do not forget that this centralized server holds all the authority over all the funds that were deposited. And it is very much possible for anyone controlling the centralized server to direct the smart contract to transfer all those funds to their own address. It is possible. And all these issues, all these pitfalls of centralization can only be solved using decentralization. Let us now see how the decentralized bridge really solves this issue. Between the decentralized and centralized, everything is same. What is really different here is the relay. Now, in the case of decentralized bridge, instead of a single server, there are multiple validator nodes running. And what these validator nodes do is sense transactions on the source chain and submit attestations for those transactions on the destination chain. Like if I have to, again, transfer ETH from Sepolia to Polygon, what I would do is, as always, deposit Sepolia ETH on the Sepolia smart contract. And then all these validator nodes, they would find that transaction on the source chain and then attest uh, all the details of that transaction on the Polygon smart contract. And if this destination chain it receives enough attestations, it would deposit ETH to that very same account of mine on the Polygon network. Um, what you might be thinking is, can't these validator nodes act malicious? Like they may submit attestation for transactions that do not even exist, or they may attest transactions with wrongful details with respect to the address of the recipient or the amount involved. While all these things are possible, these validators, they are encouraged not to act malicious. You see, in order to attest transactions, these validators have to stake Ethereum on the network as collateral for their attestations. And if it is later found out that the attestations that they have submitted, they're wrong, they are not truthful, their Ethereum is confiscated. And it is actually generally assumed that majority of validators will always be honest. And this assumption is actually at the core of this implementation of this design. And this design is termed a proof of stake. The stake is coming from the stake that the validators have put as collateral here. Since the network is decentralized, literally anybody can run a validator node, and we can find the instructions here. This GitHub repository has all the steps and the code required to run the validator node, which is nothing but a simple Node.js server. We basically need to stake some Ethereum on both the Sepolia and Polygon chains, and we are good to go. And similar to how the Ethereum that we have staked would be confiscated if we submit wrong transaction attestations, if we do not act malicious, we also earn some way ETH on each transaction that we attest. So that is basically the motivation for people to run the validator node. That was it for this exchange app. There are a lot of other features that I would highly encourage you to explore. I would be putting the link to this app below this video in the description, and you can find out more about me at www.pawanudasi.tech. And I'll be happy to have your views in this contact me section. That's about it. Ta-da.